We now have an expert talk, and the topic will be the future of trust with AI, cracking down digital warfare and misinformation. We have with us this evening Andreas Diana, Chief Product Officer, Accrete.ai, as a speaker. Andreas is a trading veteran with 15 years of experience as an active investor across the capital structure. His experience as both a discretionary and quantitative trader gives him a keen understanding of how markets move and where opportunities for cognitive products are the greatest. Pleasure to have you here with us this evening, Andreas. Over to you.
Thank you, Justin, for the introduction. So today we're going to be talking about the future of trust with AI and how we can crack down on digital warfare and misinformation in this new arena that we find ourselves in. So who am I and who is Accrete? So the company that work for Accrete, it delivers configurable dual-use AI solutions. So what does dual-use mean? That means production-grade AI that is both for military and commercial applications. And the goal that we have is that we automate complex analytical workflows with a specific focus around defense, intelligence, and cybersecurity. Our philosophy is that AI is going to change the world, and we want to make it as accessible to everyone as humanly possible, not just PhDs. And in order for that to happen, we need to create AI that is learning continuously, naturally, alongside us, that doesn't require inordinate amounts of manual labeling. And that is what can unleash our true creativity. So what we've done is we've built a learning platform of modular components we call knowledge functions that are each designed to solve a universal cognition problem that cuts across a variety of different use cases. Now, how does that apply to the problem of misinformation? So the problem that we face today is really twofold. Number one is, how is misinformation being used in digital warfare and how can we tackle it? And there's so much really just regular information out there that that's coming from so many different channels without even considering misinformation that it's very difficult to separate the signal from the noise. And that cuts across both government and commercial sectors alike. Now, when you compound that, the problem only gets harder when you have foreign actors that are deliberately flooding those same channels that are already flush with information with additional misinformation. And then secondly, an AI solution, in order for it to be effective to fight misinformation, it needs to be trustworthy. And there is still a major lack of trust towards AI systems. So we can't just build systems that deliver valuable insights. We also have to build them in such a way that users can understand them and what is the reasoning behind those insights so they can actually trust them sufficiently to begin to incorporate them into their workflows. So let's tackle the first problem here of misinformation, or talk about it. So first and foremost, we have information overload. And that simply occurs when there's more, the input into the system is exceeding the amount of processing capacity that it has. It's pretty obvious that for human biology, the limits that we have completely prevent us from processing the total amount of information that's generated even every second, let alone every hour, day, week, or month. But what is not as obvious is that even standard data analytics and machine learning tools struggle with parsing through the quantity of information that's out there and making sense of it all. And so information overload and misinformation are related problems because they're intimately connected. The tools that help us wrangle information overload can also help us wrangle misinformation as well. Because with more information existing in the world, it's very easy to obfuscate misinformation in the mounds of publicly available unstructured data that exist. With that misinformation buried in that inordinate amount of public information, we all too often either fail to detect that misinformation altogether, or when we do so, it's already far too late to do anything useful about it. And so problems such as phishing, identity theft, political influencing, disinformation campaigns become extremely difficult to fight using standard tools. So how does Accrete tackle misinformation? And it really comes down to detecting what we call target insight detection. And we do this in a number of different products today. Target insight is simply information that meet certain predefined criteria. And the various products and forms of insight detection have built on each other in our product suite over time as our capacity set has expanded. So in media and entertainment, we have target insight detection of trying to find artists with the highest likelihood of going viral on the internet and thus have the highest possibility of commercial viability. And this is an information overload problem due to simply the amount of content creation that is happening every day. In a government use case, we are tasked with finding entities that display anomalous behavior that could otherwise hurt a supply chain. And this is both an information overload and a misinformation problem because there are companies deliberately hiding the fact that they are government-controlled entities to avoid sanctions. And in our current government work, that's currently under development, we're looking for information that is not true, but is being used maliciously. Now, switching over to trust and AI, how do we think about that? So there are various AI and deep learning networks that achieve impressive results. But in the real world, the organizations that utilize these really struggle with trusting the outputs, especially when you're dealing with highly sensitive and critical work. And the problem is what is dubbed black box AI. So black box AI is simply shorthand for models that are sufficiently complex that they're not straightforward to understand. And people and organizations have concerns trusting them because they can't understand how the machine arrived at its decision. And if something goes wrong with that machine, people won't understand why it happened or how to go about fixing it. And the concerns that abound with this include potential bias. Who is accountable when you use the recommendations of a black box system? Is it the person? Is it the person that created the machine, the person that took the recommendation, or the person that created the model? And there's concerns about accuracy moving forward, because if you don't know how it works, you won't know how it will behave in the future. And that could lead to real disastrous consequences down the line. So our philosophy is that we put explainability at the center or the core of all of our products and our AI platform in order to combat this problem with trust in AI. And to give you some concrete examples of the types of products that we build, I want to showcase for you a few of them now. This one we call Supernova. Its intention is to uncover tomorrow's top talent today, as we like to say. So the idea is that social chatter holds and buries clues, help us predict what artist is going to blow up in the future. And if we leverage that commentary surrounding the artist in an intelligent way, we can actually surface those artists that are attracting an authentic audience, growing that audience rapidly, and do so across a multitude of platforms while providing predictive transparency back to the user. And the problem in this domain is that there's simply an inordinate amount of talent that's coming online every day, creating just as much content, and all of the interactions with their audience are just an enormous amount of data to try to make sense of. So what this product does is it continuously monitors a whole range of different platforms and their data to unify them into one ground truth for a particular artist. It then grabs high-level statistical data as well as digging deeper into the data to come up with these complex derived features like authenticity and engagement, which we can then merge with the statistical data to provide a much higher fidelity signal of the value of all the user-generated content surrounding an artist. The way to think about this simply is that not all likes are created equally. Not every follower has the same clout. So you can't weigh them all the same way either. And what we do then is store all of this information and display it into a knowledge graph, as you kind of see over here on the right in the image, which has underpinned both this product and laid the foundation for our government product, Argus, which I'll talk about next. So Argus is our product that is being used currently by the US government. And this is one of the examples of this dual use open source intelligence gathering application that is configurable for a variety of different use cases. So today, it's helping the US Department of Defense detect anomalies in a US supply chain. The governments of today, not just the US, are really engaged in a new kind of war. And that war is, or national security, I should say, not war necessarily. It's expanded well beyond just the physical battlefield into this nebulous virtual arena that's fought on virtual grounds. And the strategic weapons and tools necessary for this new battle space are really centered around understanding dynamic unstructured data in a massively scalable way. So governments want to understand, for example, which companies are under foreign government influence or control and to what degree. And specifically in this case, it was for a business supply chain. And it really helps a government analyst answer two types of questions. Both A, the questions they know to ask, and B, the questions they don't know to ask, but they want to explore the data around them. It's really powered exclusively by public news sources and other data sources, which is really interesting because these are both structured and unstructured data sources. And what the government has realized is that by harnessing publicly available data, that can be just as valuable to national security as classified information has been in the past. And all of this is done without requiring the user to do any kind of labeling. The normalization of that data into unified ground truths is done automatically for them. And it does this in a variety of different languages as well. And because Argus is configurable, we can rapidly adapt it to different use cases and have already done so. I'll try to briefly show you the version that we have for supply chain risk management. And we've also configured a use case for reverse engineering that's being developed right now as well. And our latest effort is around developing a new use case that combines aspects of Argus with Supernova around social intelligence and misinformation, the very topic of this discussion. To give you a sense of the statistics surrounding Argus today, We've collected a total of 45 million documents, and that's growing at about 1 million documents every week. There's 12 million entities that have been found from within those documents and other data sources as well. 200 million relationships inferred from that discovery. And all of this, and 12,000 investment projects that have been collected, and all of this continues to grow every day. What Argus is doing today would cost the DoD, we estimate, around $240 million in terms of manpower, which would require about 2,000 analysts per year to replicate. And that doesn't even take into account how much insight is worth to the government when we catch something that a traditional method might otherwise miss. And so to briefly look at what Argus does for an analyst workflow, this is the facade that allows you to explore the data when you know what questions to ask. So it works a lot like any search engine. You type in a query up at the top and you get a list of results. But these results are fine-tuned to the type of analyst that utilizes the system and grows more accurate as analysts utilize it over time. You can visualize the information in a semantic map, which is shown over here. So you can refine your query without having to type in complex terms. You can understand that this bubble here has to do with the armed forces. And if I want to just look at results pertaining to the armed forces, I can select that, and that's all I will see. Furthermore, I can understand the result sets from a geospatial perspective. So in this case, I've typed in hypersonic weapons test, and it turns out that a lot of activity is occurring around the Korean Peninsula, which I don't have to go in and read through all these articles to understand. I can do this very quickly and filter all this information in a way that allows me to rapidly go through my workflow. Similarly, in terms of identifying government influence, we have what we call our influence facade here that allows me to type in a particular entity, or I can simply search by geography, company type, entity type, relationship types, and see what are all the entities that an entity of interest or a region of interest are connected to, and how connected are they to a foreign government that I might care to understand how that would affect that entity that might be critical to my supply chain. And anywhere we find anomalies, that is discovered by this graph as well with the little red borders. And anomalies could be indicative of companies that are trying to obfuscate the fact that they are a shell corporation, for instance, because they're trying to evade sanctions of a foreign government. This tool helps you surface all that. And as I mentioned before, with explainability as to how we arrive at these scores for each individual entity. This is done through a rather complex algorithm that I can't get into today. However, you can see that we try to be as transparent as to how those values are arrived at so that an analyst can both understand it and communicate that to his or her superiors as necessary. Now, switching back to the presentation, what our next that we're working on now, it leverages, much like Supernova has, social chatter, which again helps us not only understand which artists are going to blow up, but it can also help us identify which bad actors are gaining traction in a particular region rapidly. Works typically initiate or spread misinformation, and how well are positive narratives that are maybe spreading through those same regions taking root or not, that we care about taking root in those particular regions. So what this is the retooling of Argus for a social intelligence use case, and it will be designed to do two key things. Number one, measure that narrative engagement for narratives that, say, the US government or another government wants to promote in a particular region, and allow you to custom define, map, and monitor networks that you care about in a particular region as well. So what that means is you can create a synthetic, cross-platform, definable, and filterable social network. Could take certain accounts from, say, Twitter, other accounts from Facebook, other accounts from elsewhere, and automatically grow that network based on predefined criteria to incorporate new nodes and then see what is happening in those particular regions. And to show you how that would actually work, I'll walk you through a very brief workflow of creating one of those networks. So I can select a source or a number of sources, such as Twitter, TikTok, and vContact, select what aspects of those particular sources I want to monitor, be it hashtags, mentions, specific accounts, etc. Save that network, and now I have my synthetic network that's created. I can explore it and see what are some of the nodes what are they saying, either in English or in the original language that it's pulling from. And once I have this network created, I can now go and analyze what is the chatter that is surrounding that network and filter it by sentiment, by hashtags, by topics, to really understand what is occurring in that particular region, or in that particular region geospatially, or that region virtually as well. And then I can get summary data to see how that evolves over time, again, geospatially or within the network. So this is the data point at time A. And then I can see what that data looks like at time B and how much it's spread across the globe, be that on a topic basis, on a hashtag basis, or on other bases as well. And here we can just see some of the modules that we have in Supernova that show us sentiment and the prevalence of a particular topic over time to see how those topics relate to each other and how much ground they are gaining or losing relative to the other topics that are occurring within that particular network. So to wrap up, I want to just touch briefly on what the key technical differentiators are that Accrete has that really make all of this possible. The first is that all of this doesn't require painful manual labeling on the user's part. So the AI is learning implicitly by example, not by explicit rules that are required in many other solutions that are out there. Furthermore, it's effortlessly growing its accuracy. So we don't put anything out there unless the accuracy can increase at a rate that's inversely proportionate to the amount of effort required to train it. We are continuously and dynamically learning, so we don't batch process our models. The model continuously improves over time without having to be redeployed. It's happening automatically in the back end, and there's seamless transfer learning occurring as well. So we can take one model for one context, be that in finance or elsewhere, and leverage everything that it's learned there to get a much better starting point for a new model that might be utilized in a different context that we can then branch and start to train in that new arena. And so some closing thoughts to leave you with include, around this concept of misinformation is that in order to really tackle misinformation, you have to start by tackling information overload. Because if we can't make sense of the cacophony of information that's already out there, we can't possibly start to separate fact from fiction. Secondly, we have to map and normalize the networks that might be of interest to us, as I just showed, in an automated way so that we can really understand the flows of misinformation. So what that means is a custom defined network that we can monitor its behavior can be just as valuable to identifying misinformation as the information itself, because by looking at that behavior of the network, we can understand what they're actually trying to do. And finally, as I mentioned before, explainability, we believe, is mandatory for institutional adoption and trust. No matter how good your system is, if you can't explain it, if your trust is weak or non-existent, then you will never gain adoption institutionally over time. So with that, I just want to thank the organizers at NASSCOM for inviting me and Accrete to speak with you today. Hopefully you found this presentation valuable and it's given you a few unique insights into the different ways of tackling misinformation. Of course, if you have any questions, feel free to reach out to me. My contact information can be found through the conference or here at the bottom of the slide. So thank you once again, and I will turn it back to Justin.
Thank you, Andreas, for your time and for sharing your insights with us this evening.